Hi everyone, hope you are all fine. Today we are going to solve 4 new questions from social media. So let's start. So this is our first question. Here we have some numerical values and the question asks us to simplify. So to simplify this, one way you can calculate this and this, then add them and divide by 7, but it will take a long time. So you will lose too much time. So no need to do that one. The easy way is, let's try to find something common for these two. So 3 power 7, we can write in this way. 3 power 3 times 3 power 4. So we use the multiplication rule for indices. And then if you look at carefully, these two are common for these two terms. So here there is 1 times 3 power 4. If we factorize 3 power 4, so we will have 1 plus 3 power 3. Here there is a hidden one, so that one comes here, 1 plus 3 power 3. So if we simplify this one, 3 power 3 is 3 times 3 times 3, which is 27, plus 1, 28. So before we multiply these two, so we can simplify these two numbers. So 28 divided by 7 will give us 4. So now we can multiply, but we don't need to multiply right now. After we take numbers outside square root, we can multiply. It will be easier because they will be smaller numbers. So to take it out, remember square root has a degree 2 here. Although we don't write, there is always a 2 here as a degree of the root. So to take an index outside the bracket, we divide the power of the indices by 2, which is degree of the root. So same thing, we can do it for 4, or since 4 is easy to take outside square root 4 equals just 2. So now if we simplify this, 4 over 2 is 2, 3 power 2 is 3 times 3, which is 9. So 9 times 2 equals 18. So that is the simplified version of our question. The second question is related to simplifying some fractional expressions. If you have this kind of expressions, so many things at the bottom, so we always start with the one with at the bottom. So let's start with this one. So here, so you can imagine this as a fraction, so 3 over 1. For all the fractions, if you multiply both sides by same number, the fraction will remain same. So I multiply both sides of this number by 3. So it becomes 9 over 3. Now, if bottoms are same, we can add the tops. So 9 plus 2 divided by 3, 11 over 3. So we get this as 11 over 3. After this, we have 1 over 11 over 3. See? So we have this part. So first we need to simplify this before we start addition. So here in green color, we simplify 1 over 11 over 3. 1 over, this means division. So we can write in the new form. So 1 divided by 11 over 3. So remember, for dividing fractions, this division turns into the multiplication, and we flip this fraction, so it becomes 3 over 11. So 1 times 3 over 11 is 3 over 11. So this becomes just 3 over 11. Now we can continue with this addition. So here, as you see, we show how to add them. Again, you can consider this as 1 over 1 and multiply both sides by 11. So you will end up with this fraction. If the bottoms are same for two fractions, we can add simply the top parts. So 3 plus 11 is 14 over 11. So simplified version of this is 14 over 11. So we write 14 over 11. Now we have 2 divided by 14 over 11. So same idea we used in this green part, we will apply for this. So this big fraction bar means division. So instead of this, we wrote it in this way. So division means multiply with the inverse of our function. So instead of 14 over 11, we write 11 over 14, and we multiply them. So in multiplication, we multiply tops together and bottoms together. So it becomes 22 over 14. Or during multiplication, we can do simplification. So divide by 2, 1, divide by 2, 7. So 11 over 7. So this is the simplest form of this fractional expression. Now the question number 3, here we have two functions, f and g. They are logarithmic functions, and the question asks a composite function related to gf. So before we start, we have two simple rules. Let's say this is rule number 1, this is rule number 2. Rule number says ln e. So natural logarithm of e is 1, and another one is if you have a logarithmic expression for an indices, so this power becomes product. Okay, so keep these two rules in mind. Now let's first calculate what is this f function e power e. So now what we are going to do is, let's first write what is this means. So since f function is ln x, so we write ln e power e. So according to rule number 2, if there is a power, it becomes product. So this is the power of our e, our number, so it will become the product. Now ln e equals 1 according to rule number 1, and this whole expression equals e power e times 1, which is e power e. Now we found out that this equals e power e. Now instead of this one, we can write e power e. So g function e power e. Now let's go back to the g function. This is ln e power e. Now we use the same rule, the rule number 2 again. Now the power is only e. So this power becomes product, and ln e is 1 according to rule number 1. So this becomes 1. So we have only ln e. And again, rule number 1 says ln e is 1. So the final answer for this question is just 1. So let's go to the final question. So this is our final question. The question is about solving, finding minimum for this expression, and there's a relation given between these expressions, x, y, z. Now to solve this, first we need to write all these x, y, z in terms of one letter. If the common ratio is k, so we can write x, y, and z in terms of k. For example, x plus 2 divided by 3 equals k. So x plus 2 equals 3 times k. So we have this one. So x equals 3k minus 2. Likewise, we can get y plus 3 equals 4k, z minus 5 equals 6k. And if we make y and z subject of the equation, y equals 4k minus 3 and z equals 6k minus 5. Now we have x, y, z in terms of k. Now what we are going to do is I will write these expressions in terms of k. So 2x squared, 3y squared, and negative z squared. So instead of x, we write 3k minus 2. Instead of y, we write 4k minus 3. Instead of z, we write 6k plus 5. Now we take the square and multiply by 2. Again, take square, multiply by 3. Take square and multiply by negative 1. So we have these expressions for 2x squared, 3y squared, and negative z squared. So to get this whole expression, we need to add all these ones, and we need to add all these ones. So if we add them, we have our expression, and we have simplified version of these together. As you see, this is a quadratic function in terms of k. So we can call it fk to make it simpler instead of writing this part. So we have a fk function. It's a quadratic function. Remember, if this coefficient of k squared is positive, quadratic function is like u-shape, and the minimum of u-shape is at the bottom. So it means we need to find bottom k value. So to do this, there are two ways. One, you can use the formula. So this bottom point equals x equals or k equals negative b over 2a. Or we can use the derivative function. So if we take the first derivative and make it equal to 0, so the solution of k is the bottom value, this value, because the tangent will be 0 or slope will be 0, and the first derivative gives us the slope. So if slope is 0, what k value give us that 0 slope, which is this one, 2.6. Now, if we substitute that k equals 2.6 into our function, fk function, or this one, fk function, so we are going to get the minimum value of this. So the final answer, what I get is this one, if I calculated everything correct. So the question is not that hard, but it takes long time. But definitely you need to know the quadratics or derivatives. So without these two, it will be hard to solve this question. So thank you very much for today. See you in the next video. Please don't forget to subscribe our channel to get notification about our new videos. Bye.